Hello students, now today we will know about what is the position of the dielectric, the nature of the dielectric, or the phenomena, the behavior of a dielectric, that is the non-polar dielectric, on the application of the electric field. So if we apply the electric field, if we apply an electric field in case of non-polar dielectrics, then the positive charges, that is the center of gravity of the positive charges, actually move in the direction of the electric field, and the negative charges, that means the electrons, are away from this electric field. So on the application of the electric field on the dielectric, which are non-polar dielectric, then the electrons will move opposite to the applied electric field, and the positive charges are moving along the direction of the electric field. So this phenomena is called polarization. Now if we simplify this polarization in a different manner, or if we define the polarization, then the stretching of dielectric atoms due to the displacement of charges in an atoms under the action of the applied electric field is called the polarization. So what is polarization? Polarization is nothing but the stretching of dielectric atoms due to the displacement of charges in the atoms under the action of the applied electric field is called the polarization. So this is the basic phenomena of polarization. Now in case of dielectric, or in case of electric field produced in a particular case of material, from the Gauss's theorem we know that electric field is nothing but sigma by epsilon naught in case of conductor. Now that sigma is the induced charge density or induced surface charge density. For the application in case of dielectric slab, the electric field are of two types. One is called the induced electric field, which is actually field given to the place of conductor, that is the E0, and EP is the polarization part. So if we place two conducting material and in between them a dielectric material is placed, then there are two kind of polarization. One is polarized electric field, another one is the essential, which is induced electric field. So the total electric field, that is reduced value of electric field, is like E equal to E0 minus EP. That E0 is the induced electric field, and due to the polarization, first of all this electric field actually polarize those electrons or polarize the dielectric materials, and then the residue will be the remaining part of the electric field inside a dielectric. So inside a dielectric, if E0 is applied on a dielectric, then the amount of electric field creating inside a dielectric should be E. If E is that amount of electric field which is termed as the reduced value of electric field, that E should be equal to E0 minus EP. E0 minus EP. Now there are some definition regarding dielectric constant. So what is dielectric constant? The ratio of the strength of the applied electric field to the strength of the reduced value of electric field on placing the dielectric between the plates of a capacitor is called dielectric constant of the dielectric medium. So there are two kinds of dielectric. One is the induced dielectric, which is actually induced, not, it is the applied electric field which is applied on that particular case of dielectric, and there is the reduced dielectric, reduced electric field. So the ratio of these two things are called the dielectric constant. There is also a quantity which is called polarization density. The electric induced dipole moment developed per unit volume of the dielectric slab on placing it inside the dielectric field is called polarization density. So what is polarization density? Polarization density is the induced dipole moment developed per unit volume in a dielectric slab on placing it inside an electric field is called the polarization density. So those are the common definitions and the process how a dielectric can respond on the application of electric field. Thank you.